Two particles P and Q of masses 6 kilograms and 3 kilograms respectively are connected by a light inextensible string. Particle P rests on a smooth horizontal table. The string passes over a smooth pulley fixed at the edge of the table, and Q hangs vertically. The system is released from rest. Well, let's have a look at that system. So if we have our horizontal table here, and then that's the edge of the table, and we've got a pulley here at the edge. Now we've got Q hanging here, and we know that its mass is 3 kilograms. And that means its weight will be 3g acting downwards, and there'll be a tension in the string. And then over here, we'll have P, which is of mass 6 kilograms. And it will have a weight here and a reaction force here. And there's no friction because the table is smooth. There will be a tension force acting this way. So, if we look at Q, we have, using F equals ma, that 3g take away t is going to be equal to 3a. The acceleration will obviously be this way. Let's call that 1. If we look at P, we're going to get T, which is the only force acting horizontally, and therefore that's the resultant force, is going to be equal to 6a. If I now do 1 add 2, the t's cancel, I get 3g is 9a, therefore a is equal to 3g over 9, and if we take g is 9.8, so we've got 3 times 9.8 divided by 9 gives us 3.26 recurring meters per second squared. And in part B, we want the tension of the string, and we can see from 2 that that's just equal to 6a, so that's going to be 6 times 3.26 recurring. So I'm just going to multiply my last answer by 6 and get 19.6 newtons. And finally, we want the resultant force acting on the pulley. So if we consider the pulley, we've got T, 19.6 newtons acting that way, and 19.6 newtons acting that way. So we can draw a force diagram. 19.6, 19.6. Clearly this is an isosceles triangle, so this is 45 degrees. And then R is going to be the square root of 19.6 squared plus 19.6 squared. So we've got the square root 19.6 squared add 19.6 squared gives us 27.7 newtons, correct to 1 decimal place.